Right. So we're moving into limits today. And so if you go on to calculus, there's three main topics in calculus. There are limits, derivatives, and integrals. So this is like really setting you up for that. So I think it's exciting because this whole class is like pre-calculus, and this is the first thing that's actually calculus. So. So limits, basically it's just like as you're approaching some x value, what's happening with your graph. So we read those as, like if you're looking down here, it's the limit as t approaches 0 of whatever function. You can do limits from the left side and the right side. So that's going to be denoted with like a little plus or a minus beside that number. So I think you can see that like over here, you have left-sided limits or right-sided limits. We're going to do them from a table first. So we're going to see as our x value or our t value approaches 0, then your y values are also going to approach some number, and we're going to see what that value is. So that's what we're going to do first. So I think there's a way to do this in a table in your graph, but I think it's a lot more complicated than it's actually worth. So we're just going to plug in all these t values into our function and see what you get. Does that make any sense? So yeah, like I said, you need your calculator. So grab that and we'll start typing stuff in. So we're going to plug in 0.5 first. So we'll be doing a big division, square root. So we're going to go like 5 decimal places so we can really see what's happening. So we'll put 0.16552. That all right? So y'all know how to like arrow up and copy paste, but you don't have to type the whole thing again, right? Arrow up, highlight it, the part that we want, hit enter, and then we're just going to change out that 0.5 for a 0.1. So just arrow up. So arrow up, highlight it, and then hit enter. And you can just edit out whatever you want to. Correct. So are we right getting all those values there? Okay, so that's like our limit from the right. So those numbers are going to get closer to 0 from the right-hand side, so like they're positive. Does that make sense? And then the second table you've got there is from the left, so those are like your negative values. So again, as we're getting closer and closer to 0, our y values are going to approach a number as well. If we go and just plug in a negative 0.5, because it's squared, those places where we have a t, is anything going to change? No. So both of these tables are approaching what value? They're approaching 0.1666 repeating, right? So what is that as like a fraction? Anybody know? It's 1/6. Glad we know this. So do y'all know how to like get a fraction from a decimal on your calculator? So if you like get that number and then you go to menu and then choose number, you can approximate to a fraction from there. Oh, cool. That worked out nicely. It's supposed to be 1/6. Yeah. I don't know why that didn't work, but anywho, it's 1/6. So if you left that as a decimal, it's totally fine. Like on a test or something like that, it'd be okay. If it was like your exam at the end of the year and you had this decimal, but all the answer choices were fractions, what could you do? Just plug them in. You've got your calculator. Just find the ones that are equal. If that makes sense. Yep, you do. So y'all are gonna crush it, right? Good. All right. So that's the limit from a table. Are we okay? Yeah, that's fine. Does that make sense though? Do we have questions there? Y'all, focus. Questions. Do we have any? No. Okay, good. So we're going to do the same thing again. This time the table is not given to you. So we're going to have to like make it ourselves. So x is approaching 1 this time. So we need some values that are going to get close to 1 on the left-hand side. So think about numbers that are less than 1. What's less than 1 but super, super close to 1? Okay, so we're going to start with 0.9. So I'm just going to make a little x and f of x. So we can do 0.9, and then what's even closer to 1? And one more time. There we go. That okay? So that's coming in from the left-hand side, right? Because all those numbers are smaller than 1. So if we want to come in from the right-hand side, we want numbers that are bigger than 1, but still really close. So what can we try? So 1.1, 1.01, and what else? So I went backwards on that just because, like, in my head it makes sense for, like, 1 to be in the middle right here. And, like, if I did those the other way around, I wouldn't like how the table looks. But anywho. So as we get closer to 1 this way, your y value should also get closer to some number. So we're going to see what that is. So we're doing it the exact same way as we did the one up top. You're just going to plug in 0.9 into your function, 0.99, 0.999. Yeah. Y'all okay to do that on your own right now? We're just plugging in those values. So we should be okay with that. Let's go 4 decimal places this time. So what does it look like we're approaching? What are we getting super close to? 0.5, right? Because we got really close to 0.5, and then if you go like this way, you're coming closer to 0.5 again. So we would say as x approaches 1, y is going to approach 1/2. That's how you would like talk about this limit, I guess. So as approaching 1. And you can see that on the graph that's over here. So especially when it gets to be like fractions, sometimes it's hard to tell on the graph exactly what it's approaching. But yeah, that's going on there. Find the limit, estimating. Using the graph or the restrictions. So if we look back at like our function here, you've got x minus 1 over x squared minus 1. So we could factor out your denominator, right? So we have x minus 1 over what? Times 1x plus 1. So the minus 1's cancel. And you're really just left with 1 over x plus 1. So that means that you can't have x equals negative 1, right? Which is why we have that vertical asymptote right there. And then also you had factors cancel. So that's going to give you a whole at positive 1, which is what they have going on here. So yeah, just remember those things. So what's going to happen is they're going to ask you like what's the limit as x approaches 1, so we could say that it's going to get super close to 1/2, right? But if it asks us the value of your function at 1, that would be undefined, right? Because there's actually a hole there. Does that make sense? So this is where limits are useful, so we can see what it's approaching even if it's not actually defined at a point. Questions? All right, so there are a few cases where limits do not exist. Those are at the bottom of your page right here. So if you have a jump or a gap, and essentially it's just saying that the left-hand side and the right-hand side do not come into the same place, then the limit is not going to exist at that point. So like for this graph, we are at 0 and then we jump up to 1. So the limit as x approaches 0 does not exist. So the way that you could like prove that would, you would say the limit as x approaches 0 from the left of h of t does not equal the limit as x approaches 0 from the right of h of t. Limit, L-I-M, that's how you write that. The limit as x approaches 0 from the left of h of t does not equal the limit as x approaches 0 from the right of h of t. I'm sorry. It's just talking about it right at that case. So this is just like one point where it doesn't exist. They could ask you the limit at any number at all. It's like we're going to do that in a minute. You have one graph and they're asking you about like 5 different limits. So it's just at that point the limit does not exist. What's that? Like, is this always the function that you're going to use?
Yeah.
No. It'll be different every single time. So it's just an example. So you would still just like plug numbers in. So on left and right sides of whatever you're approaching. Yeah. Is that okay? Questions? Anything else we're not sure about right now? Alright, so yesterday y'all remember how we said that like if your function oscillates, that it like diverges, right? So this is what that looks like. And so if you have that happening, then we say that the limit does not exist either, because it's not approaching one specific place. It's just going to go back and forth and back and forth and back and forth. So if this ever happens, your limit does not exist either, because it's not approaching any set value. And then the last case we have for your limit not existing is if you have a vertical asymptote. So that's going to go to infinity, and if you go on to calculus, we handle that differently. But for y'all in this class, you just say that it does not exist, okay? So if you're going towards infinities, like we are here, so like as x approaches 0, your y values are unbounded for forever, then you just say that it does not exist. Is that okay? Right. But it was not asking us the limit at -1 where that vertical asymptote was. So they're going to give you like graphs and then ask you a bunch of different limits. So it's going to just depend on what number you're approaching for x as far as like what's happening with your graph. So we're going to handle that now. You ready to try some? Okay. So right up top, this is what I was talking about earlier with your left-sided limits and your right-sided limits. So in order for a limit to exist, you just have to make sure that the left side equals the left, or the right side, left and right side equal each other. That's all that this is saying. So we're gonna like go through that with these down here. So here's your graph. The first one wants the limit as x approaches 2 from the left. So if you look at 2, coming in from the left, what are we approaching? At 2, coming in from the left, what is the graph approaching? What y value? 3. Does that make any sense? So then part B there, what's the limit as x approaches 2 from the right? So again, looking at when x equals 2, coming in from the right, what are we approaching? 1. So does the left-hand side equal the right-hand side? No. So the general limit, not specific to one side or the other, does not exist. So you can put D and E for those. Is that all right? Questions? All right, so the next one we're looking at as x approaches 5 from the left. So we're looking when x is 5 from the left, what are we approaching? 2. Now, what about 5 from the right? So you're coming in from the right side, you're still approaching 2. So if they asked you the limit as x approaches 5, was it the same on the left side and the right side? Yes, and what value was that? 2, so that's what your answer would be there. Is that okay? What if they asked you g of 5? Would it still be 2? Why not? Correct. There's a hole there, so you'd have to say, like, what is that, like 1.5 maybe? 1.5? Is that okay? Does that make sense? Questions? Anything we're not sure about? Don't understand there? Alright, so we are almost done. On the bottom set, you're given like a piecewise function up here, which as long as you have the graph, you don't necessarily need this, but it's there in case you want it. So we're looking at the limit as x approaches 1 from the left. So looking at 1, coming in from the left, what are we approaching? 2. And then looking at 1 from the right. So 1 from the right, what are you approaching? 3. So then the general limit, are these two numbers the same? No, so what would we say? Does not exist. Questions? So that's basically all there is to it for today. So are we good?